Okay, so applications, real life questions. So we've got a ship is anchored in a tidal harbour. That means the water goes up and down, like the tide. The depth, d meters, of the water, t hours after midnight on Sunday night, is given by the function d of t equals 7 plus 2 sine pi t over 6, also known as pi over 6 times t. Right? The first question is state the maximum and minimum depths of the water during Monday. So talking about maximum and minimum depths. What do we usually look for in a function that gives us a maximum and a minimum?
Range.
Yes. There you go. Range gives us our peak, top peak, and our bottom peak. Right? So look for the range. How do we find the range of a period function? No. That's the period. We're looking for range. But keep in mind that it's been moved up by 7. So we've got to add that into our range. So negative a plus k and a plus k. That's how we find our range. What is a? Our amplitude? Yes. And what is k? Our vertical translation? 7. We get negative 2 plus 7 and 2 plus 7. Always keep in mind that your amplitude, don't pay attention to the positive and negatives. The amplitude is a distance. So it'll only ever be positive. Negative 2 plus 7? Yeah, 5 and 9. So the minimum is 5 meters. And the maximum height is 9 meters. Yep, so the period equals 2 pi over n. What is n?
It's number before x.
Yeah. What is like x in this situation?
1, 5, 6, 7.
Right, x in this situation is t. What's in front of the t? Pi on 6. Because you can also write this as pi on 6 t, if you would like. Right, it's the same thing. So n equals pi on 6. So we have the period is 2 pi on 6. How do we divide fractions? We flip the second one. So it'll be 2 pi times 6 on pi, which is 12 pi on pi. We cancel those out. We get 12. And because t is talking about hours, 12 hours. So you get a high tide and low tide every 12 hours.
Could you write 12t? Because t is hours. Yeah, I guess so.
Yeah, I guess so. 12.
I wouldn't recommend it.
12. Yeah.
Because it's an application problem, so you've got to relate it to.
Yeah, you've got to say what like the real life kind of answer is. Yeah. 12 t
And then
t
you're more
hours.
You're more likely to get muddled up too if you're using more.
Yeah. No, I don't think you can because t equals 12. Because t is a number. Because if you said 12t, then you'd be multiplying 12 by what t, the number of hours, which is not correct. Yeah, yeah.
But you need to put hours on the end. Surely we can write.
Yeah.
A few extra.
Okay. Yep. So call that d of t. And we call this one t. Gonna go up to 9. And we'll do 5 about there and 7 halfway. We'll do 24 hours here. Halfway is 12 hours. That's 18. That's 6. You can fill it in more if you want to. Always use a ruler as well.
Oh, yes.
Measure, intervals. Okay, so we know that's going to go around this line. This is the middle line of the graph. And it's going to go oscillate up between 5 and 9. So we know that one whole period is between 0 and 12. So it's going to start here and finish here. It's going to go through that line exactly halfway between. Yep. We might add in some extra intervals. 3, 9, 15, and 21. Halfway between the first 2 points, it's going to hit its maximum because it's a positive sine graph. And halfway between the second 2, it's going to hit its minimum. Do the same for the next period. So it's going to start at 12 and end at 24. Exactly halfway, it's going to go through that line again. Halfway between the first 2, it's going to hit the maximum. Halfway between the second 2, it's going to hit the minimum. And then we can just join them up. Whoops. Yeah. Try that one again. There. Remember in your test that a line is a single line. It's not feathered strokes all the way around, and it's not looks like you've been traced over it 100 times back and forth. Okay, it's one single line. Do it with a pencil first, and then if you want to, you can trace over it in pen, or you can leave it in pencil.
Do we lose any marks if it doesn't look like smooth like that? And it's just like looks like triangles.
Like this? Well, no, because then that's a hybrid linear function.
We'll lose marks.
Yeah, you will.
We get no marks. What if the right means not a hybrid linear function?
Or you could just draw it correctly. You know that it's supposed to be curved, so draw it curvy. Right, so we're above 7 meters here and here. Yes, sorry. That's 12 a.m. And 6 hours after midnight is 6 a.m. We've got 12 p.m. and 18 is 6 p.m.
You have to write 6 p.m. though?
Yeah.
18.
Oh, if you wrote it as what, like 1800 hours? Yeah, you could do that. But it's got to be in a time, not in hours. You got to read the question carefully. Okay, what times are high tide? And instead of looking at your graph and answering this, because it might not be super accurate, I want you to try and work it out algebraically.
What's the question?
What times are high tide? When is it high tide? So when does our graph reach its maximum?
At 3 o'clock a.m.
No, he said don't look at the graph. Work it out algebraically.
Oh, sub in earlies.
No?
Yes.
3, right?
Yes.
You know the
Yes.
period
You would sub in
12, and so if you half it and then half it again.
No. We want to work it out algebraically, substituting in some sort of number. Right? Yeah, 9 is what? Is it the depth or is it the time? It's the depth. So instead of d of t, we're going to sub in 9.
Oh, so 9.
So 9 equals 7 plus 2 sine pi on 6t. Right, we'll do a little bit of rearranging. What can we get rid of first?
You can put the 9 on the other side.
No, we're trying to get t on its own. Take the 7 over. So you get 2 equals 2 sine pi on 6t.
On 2 equals 2.
Divide by 2?
Yes, we can. 1 equals sine pi on 6t.
And then we use the triangle thing.
Not yet. We want to get t on its own. So what do we take over the other side? Sine, yeah, and becomes. What happens when you take sine over inverse sine? Inverse sine of 1. Now, for what angles does sine equal 1? Sine is x or y. Good. So it's only here. Yes, pi on 2. But keep in mind that our graph goes through 2 cycles.
So it's 4 pi on 2.
Close. 1, 2, 3, 4, 5. Right, so we get pi on 6t equals pi on 2 and 5 pi on 2.
Take the pi on 6 over.
Yep, and divide. So pi on 2 over pi on 6 and 5 pi on 2 over pi on 6. How do we divide fractions? Flip them. So we get 6 pi on 2 pi. No, yeah, 6 pi on 2 pi. How do we simplify? We'll write it out first. 6 pi on 2 pi, yeah. Yeah, so flip that one. We get 30 pi on 2 pi. So those cancel each other out. Those cancel each other out. 6 divided by 2 and 15. So our times are times, not hours.
3 and 1500.
3 a.m.
300 and 1500.
3 a.m. and 3 p.m. 3 a.m. and 3 p.m. One last one. What is the depth of water at 10 a.m. on Monday?
Sub it in for 10.
For
17.
T. Yep. So we get d of t, 7 plus 2 sine 10 pi on 6, which can be simplified to 5 pi on 3. Good. Right, give you a hint. You got to look at the unit circle.
Oh, no, it's negative.
Yeah, negative. Yeah, you can do negative pi on 3. Right, let's work it out. Right, 5 pi on 3. 1, 2, 3, 4, 5. It's down here. 5 pi on 3 is like all the way over there. Okay, so we're pi on 3 away from 2 pi. So you could think of it as the same as pi on 3, but negative. Because you all stop to Caulfield. Sign in this quadrant is negative. Or you can just think of it like the triangle, pi on 3 triangle. There's root 3 opposite, 1 and 2. But because it goes down this way, that's actually a negative root 3. You could think of it that way.
So would it be the same if it was in the third quadrant? Would you flip it to the negative as well?
Yeah, but then also this one would be negative and this one would be negative. So it'd end up a positive because, sorry?
So would 1 and 2 be negative instead of root 3 being negative?
No, the 1 and the root 3 would be negative. So then opposite over hypotenuse, you still end up with a negative, which makes sense because only 10 is positive in that quadrant. Okay, so using pi on 3, opposite over hypotenuse, we get negative root 3 on 2. 2, negative root 3 on 2.
So then it's just, is that 9?
9.
Is it, or is it,
Just multiplying in that 2. So it'll go on top of the fraction.
Yeah.
So 7 plus, oh, it's actually a minus. Because you got the minus there. 2 root 3 on 2. Cancel out the 2's. And we get 7 minus root 3. D of t is depth in what, meters? 7 minus root 3 meters. And that is why we don't just look at our graph and estimate. Because if you had looked at your graph, you probably said, oh, probably like 6.
What is it?
Where it's, yeah, it's not 6, it's 7 minus root 3. Yeah. So unless you're absolutely sure and it exactly matches up on the graph, use your algebra instead of your graph. That's it.